Looks like it's live. We'll see. Do a test and such. As usual. Here we have. Looks like it's live. It seems good enough. Audio still makes a little noise, but too many things to fix. So it's not going to get fixed today. Yeah, so I figure I'll do some comments, I guess. And pop that up. Anyway, so I have in the past attempted to solicit anybody who would like to have conversations about physics, who kind of knows some physics, and like to discuss these different subjects about what reflections are, what surfaces do, wave versus particle kind of conversation, relativity, all that kind of mush, redshift, and yeah, lots of subjects. So yeah, send an email and let me know that you're willing to at least open your microphone and attempt conversation and such. Anyway, yeah, so maybe we'll start at the bottom, I guess. All right, somewhere around here, I think. So, no, I think one below that, actually. I don't think I ever read this one. Yeah, so that's, I guess, what we'll do. Anyway, I wonder what the reaction would be if you asked someone in the mainstream, let's move the comment up, tech world, about a tractor beam pull. I don't know. I mean, obviously, I don't think most tech people think about anything, about this whole idea of what pull would mean. I mean, in a sense, because they think these forces are some sort of magical force. They really believe in spooky actions at distances and some sort of telepathy. They don't think this has to be through some sort of physical medium or mechanism that you have to actually move these forces, and that's why they move slow, is because they're physical things and all that crap. So I don't know what they would think. Probably you watch too many movies. I don't know. Despite such a device being so useful, whatever, I don't believe much serious work is put into it because they know it is probably futile. Yeah, I just don't know if they know that realistically. I don't know. I mean, I think they just obviously don't think they have enough knowledge to be able to make pull forces, I suppose. Rockets push are not a problem, though. Yes. So yeah, I know you're sort of making an argument on my side there, but I didn't think you made it very well, so don't have much to say. Nobody has ever demonstrated how it is possible for a particle to move through truly empty space. So again, this is just almost silly because obviously we have thrown things into empty space and moved them, so it's not really a problem. People on the moon, no atmosphere there, mostly empty space, little tiny bit of atoms, but just tiny, tiny amounts, mostly empty space. And they've thrown things in the air and done things. And so, whatever. You want to somehow think that you've proven the existence of some alternative jello that exists. You haven't demonstrated how it's possible for a particle to move through jello either. How does the empty space in front? It's nothing. Empty space isn't a something in front of something. There's nothing. So this is your game you're playing. I could ask you the same question in reverse and just say, well, how does anything move if it's getting slowed down in the jello all the time? How does empty space in front know to become filled with the particle? Then it doesn't have to know anything because it doesn't exist. Why does the particle not disappear beneath the blanket of empty space as it moves? Again, there's no empty means it's not a blanket. You're just not getting it. Empty space, you can't be beneath it, you can't go under it, you can't go any through it even. It's empty. There's nothing. You're a something and you're moving. Now, you want to ask, how does motion happen? Yeah, well, that's a, who knows why the universe works that way, but it obviously works that way. Obviously, that's why there's time, because it takes time for things to move places. But what we do notice is things don't slow down. So I don't know what kind of delusions you have about why it appears that photons don't slow down. Anyway, how does empty space behind the particle know to fill up the gap it leaves? So again, just more mush, just, silly talking as if empty space is a something, not a nothing. Why does a moving particle not act like a marker pen? Why does a moving particle not act like a marker pen? I don't know what that means. None of this can work if empty space is truly empty. Yet can if the little particle is truly moving. So again, just, you make up the rules? No, the rules can be either way. You're saying you know what the rules of the universe are. You have some special knowledge. Well, you have knowledge I haven't seen. You have some notion that I haven't seen evidence of. Your whatever it is, your ether. How does your ether make energy? Because that's what you need to define gravity. Because it's impossible for nothing to know to do anything. Well, again, it's obviously nothing doesn't have to know. So, yes, it doesn't know to do anything because it doesn't do anything. It is due upon. It's not, it's not the perpetrator, it's the victim. The only other option is that the particle that moves in empty space in the front to its behind, whatever that, this is just, I shouldn't have even bothered reading this mush. This can happen by sucking and ejecting or by rotating the space around it. You can't rotate nothing. So again, you can't rotate space. So and you want to keep telling me that space has to be something. Even when I tell you it's nothing, you're saying, how can nothing be nothing? Well, nothing could be nothing because that's the rules. Nothing is nothing. Shit. Either option proves that empty space he proves something with this mush. Must be filled with an ether. Why? Why? Rotating nothing around the particle doesn't change anything at all. And where do you have any evidence of anything getting rotated in empty space? Oh, that's right, you have no evidence. It must be rotating something to produce a change in the system. So again, rotating what? Where's your evidence? So that's right, you don't have any. So whatever, just a garbage comment. No value. You have to make an argument of some kind. It's just not an argument. Your argument from, I'm going to tell you what nothing is, and nothing's a something, not a nothing. Screw you. I wonder what the reaction would be. Oh, yeah, we did that. Do you think that the universe has infinite extent? I don't know why this, again, always comes up. You would just keep harping on this stupid creation crap, and I don't know why. I have no idea why you think it's a fascinating question or why you think anybody has any special knowledge of creation. It's just an amazingly weird thing for you to worry about. So what do I think? I think it looks like it's not infinite just because if it was infinite, then we would be seeing the light from the infinite amount of stuff. So maybe I could argue it that way. There'd be an infinite number of photons heading right for us. We'd be getting hit by an infinite number of photons from the infinite number of stuff that would be infinitely in space, I think. I think theoretically, if space was infinite and it was full of photon producing entities, that we would end up, and timeless, that we would end up getting hit by all those photons. And even though they're going a very long distance and all this other crap, there's an infinite number of them. So we would be just buried under them. I mean, every bit of space would be filled with a little speck of photon. All right, I love this series you're doing with the guy. So awesome, Professor. But yes, I'm glad because it's obviously these videos haven't gotten very many views, and but I understand that why the casual physicist doesn't want to watch this stuff because it's a lot of math and a lot of bullshit and blah, blah, blah. And there's not, you know, but it's been very useful for me to do them. So, you know, and for my own understanding. So, yeah, I see value in it as a process. All right, Cato again. I would think a plain piece of glass would reflect less than 50% at 45 degrees. I don't know why you would think that, but it's fine. It's okay to think that. The real numbers, you know, I mean, it's at 90 degrees, it's 100%. Well, I mean, it's 66 degrees or something, I think. Well, whatever it is, it's some number. It's already 100% reflection. So, you know, you just kind of do the calculation, and it seems reasonable to me that 45 would be 50-50, but it doesn't matter to me that much. Yes, it would change for different angles, but then it would mess up the experiment for reflecting the light back. So I don't know what that means. Maybe different additives in the glass would change that, though. Well, like I said, you just change the angle and you sort of fix the problem. So, you know, you made an interferometer that wasn't perfectly 90 degrees. You made one that did this instead. Wouldn't change the rules that much about distance differences. Just changes them a little. Makes it more complicated, but it wouldn't make it impossible to do. Let's see, the same Aboriginals, I don't know what that means, believe the rivers were carved by a big snake. But apparently they understood shit that we can't even prove with today's technology. So they understood shit that we can't prove with today's technology. Well, so I guess he's paraphrasing their argument here. I don't know. This is an electric universe thing. Hocus pocus at best. Well, I don't even think they have that. Cave paintings from thousands of years ago are the go-to EU evidence. Well, I mean, obviously, I don't know why they're dragging this ancient astronaut kind of theory into their physics theory, but it does make it look ridiculous, in my opinion. So, you know, it does make it look like a religion. You know, they're basically saying totem poles have the truth written in them. And, you know, that's just really silly. Anyway, here is some debunking that has grit. So I went, this is a page that's already been linked to. It's a pretty lame debunk of the electric universe because the first argument starts off with, see, the electric universe people don't think there's neutrinos coming out of the sun. I don't think there are either. So the first argument is the guy makes is, well, of course there's neutrinos coming out of the sun. There's a proven, blah, blah, blah. There's no proof for any of that crap. Neutrinos is this silly, lighter than a photon matter bit or something. It's just this, it's a silly pile of nothing. So, so to me, it doesn't really have much grit when the first argument is one based on something there's lame evidence for, which are neutrinos. Lewin should also have used a neodymium magnet back then. So those kind of comments, it's okay you make, you know, thanks for making some kind of comment, but you know, you probably should contextualize the comment a little better in terms of pointing out, like, in what experiment and why neodymium would have been maybe an interesting choice or something, you know, because I don't really see why he should have. In most of those experiments, frankly, I don't see how it would make any difference. Probably. So I don't know exactly, yeah, why it's terribly relevant. I mean, obviously, it's, you know, the electromagnets were probably something they had in the warehouse, you know. So they used what they had instead of buying any new stuff. You know, obviously the magnets he has, you can see they all look like they're 150 years old. So, you know. but I don't know if they would have improved any of the experiments. Clearly, I think he should do more experiments. Some of these experiments need to be done in more than one way to demonstrate what the real truth is, you know. So, but you know, they're not going to play along with that at all. All right, so I don't really have a backup plan. I mean, there wasn't any particular video I thought I would play. I mean, I suppose I could play a little bit more of that Al-Kahiri guy or whatever the hell he is. Ken Wheeler made a totally useless video. You know, he's supposed to be talking about the double slit, and he didn't even say anything. He hasn't done his explanation video for the rolling magnets. You know, so again, you know, just a complete bullshit. Oh, do you know why this happens? Like, he knows, and then he never explains what he knows because he finds out he's probably an idiot. I think maybe I'll play something of something anyway. As there's nothing, you know, I wish there were people making physics videos, but just nobody does it except me. I mean, ones that are, you know, more than just rags about some relativity's a lie, but it's the fakers and such. It's not really much of an argument. It's certainly not an argument about anything specific, about specific experiments. And that's what we really should be arguing is specific experiments and explaining process, what you think is actually happening, and how you can do the experiment in different ways to see if you can tease the truth out of the experiment. Tease more truth, if I have to put it that way. All right, so where am I going to jump to? Get this useless comment box out of my way. Quite useless. Yeah, so I guess maybe I will choose. Maybe we'll place some more of this crap. Propaganda video.
The atmosphere at the start of the conference was grim. Confidence in quantum electrodynamics was at rock bottom. It seemed a hopeless mess. One after another,
it is a hopeless mess.
The physicists stood up and droned on despairingly about how they'd failed to find a solution. Then it was the turn of Richard Feynman. Barely 30 years old, he stood up and took his place in front of the world's most illustrious scientists and started to unveil.
I think we already heard this part, didn't we? Well, I don't know. I think we already did.
His new diagrams and equations. What happened next was astonishing. A row broke out, not so much over Feynman's weird description of reality. Physicists were used to weird by now. But because he dared to visualize what was going on. Instead of using arcane, complicated mathematics, Feynman was describing what all his virtual particles were up to, using his simple pictures.
They weren't really virtual, it's just some of them are virtual. So it's this mixture of the real things with the fake things, you know. But it's really just doing this stupid energy transfer thing that really shouldn't be that complicated. We know kind of what goes in and what goes out of systems. And the point is to figure out what changes. But like I said, and part of the big problem is they don't have a theory where they can explain charge, the plus and the minus thing, because they don't realize that there's two different forces.
There was uproar. Niels Bohr, the father of quantum mechanics, leapt from his chair in disgust. He hated Feynman's diagrams because they went completely against everything he'd devoted his whole life to. You see, he believed that atomic particles could not be visualized under...
Yes, he believed in wooey bullshit. And you're just saying, why did everybody fall for that? Why did everybody fall for some notion that nothing in the universe is as stable as everything looks? That somehow this incredibly reliable and dependable universe is somehow made of this wooey, woey, blah, blah, blah stuff. Why do people buy that?
Any circumstances. Feynman defended his new theory, trying to explain that the diagrams were simply a tool to help visualize his new equations. But the rest of the scientists, including Paul Dirac, wouldn't hear of it.
I don't think he really had new equations. He just had a way of interpreting what the equations were doing. And so he just made the time component into a vector machine, a clock, to make a vector. And so, it's not really new math. They already know how to do vectors. He, again, just made it into some way to take the time element and make it relevant to the probability. The fact that the system changes in a reliable way that recycles. I mean, this is really about, is what Newton found out, is with glass reflections and the thickness of glass, is that it just keeps recycling. You shave a little bit off, it goes from 16% reflective to 8% to 4% to 0 to 4 to 8 to 16, and then it goes down and just keeps cycling. And so all of this quantum mechanics stuff has a reliable cycle, and you can almost see that in the two-slit experiment. It's just a cycle, and that's all there is. There's nothing, it's a redundant probability.
They called him an idiot who understood nothing about quantum mechanics. Feynman ended his lecture bruised but unrepentant. He knew that his diagrams and equations were correct, if only he could convince the others.
And correct in what sense? And that, you get the right answer for the wrong reason. So yes, you figure out the simple facts of that there's something causing this redundancy in pattern, this repeating pattern to take place. And you just create a metaphor for it, a clock spinning, and with a vector. It's a metaphor. It's not the reality. It doesn't explain anything. It doesn't have anything to do with causes. It just has to do with finding another way to calculate effects. It's yuck.
That evening, Feynman met another young physicist called Julian Schwinger. Now, Schwinger was the same age as Feynman and had been identified as a child prodigy at the age of 12. Although he and Feynman had been working independently and had approached the problem of quantum electrodynamics very differently, they'd reached identical conclusions.
Right, which doesn't seem, when somebody tells you that, oh yeah, they just coincidentally, 3 people came up with the same thing at the same time, then you're basically saying that it was obviously a simple thing. So all they all figured out was, hey, these patterns are redundant. And, we could just write a formula to capture that fact that it's redundant.
With their new equations, they could solve quantum electrodynamics. And with Feynman's diagrams, they produced a theory of awesome power. Together now as allies, they planned a full frontal attack on Niels Bohr and the Conservatives. By the end of the conference, the mood in the Pennsylvania Roadhouse had changed from one of frustrated hopelessness to one of excitement and idealism. Over the next few years, their theory was fleshed out and rapidly became the most accurate and powerful theory mankind had ever had.
Just an amazing statement. The most powerful and accurate theory mankind has ever had, except they can't do gravity with it. It's one of the most obvious forces there is. It's of no use in magnetism. So the 2 biggies it's of no use for. I just, this idea that somehow this thing created some window into reality, when no, it's a gimmick that just recognized something they already knew. Newton already knew. Newton's rings. All right, it was already a known fact. Newton did the glass experiments for buggery's sake. There's just nothing profound in saying, well, we'll just call it probability. Yes, there's probability in the universe. It just does things by chance, by rolling dice, by rolling magical random dice. When we know there's a cause, it's just silly.
Despite finally being tamed, quantum electrodynamics talk of empty space seething with energy we can't feel and virtual particles we can't see.
Right, and just to account for the fact that they don't have any explanation for where the force comes from, where the energy came from to move planets into the sun, what compresses the atoms, where does the energy come from? Because they're stuck with this idiotic notion that somehow we have this magic little thing called a piece of mass, and this piece of mass is somehow contracting space. And that's not going to get them to charge, because charge is a magnification of that very force. And they don't understand how it gets magnified because they don't understand that there's two different forces, electron force and proton force. So, I mean, it all just cascades into, this is just finding, God of the gap answers to their failure to understand mechanics. So they just make up some synthetic things to fill in all these empty spaces. This is just dark matter.
It does make many people, including physicists, a little suspicious. And many skeptics might say these ghostly objects that allegedly fill the vacuum aren't actually real. Yes, the complicated mathematical equations of quantum electrodynamics seem to require them, but that doesn't itself mean they exist.
Yeah, so your complicated equations that seem so kind of obtuse and that don't really produce any magical insight into anything except saying something like, well, there's 6 faces on the dice and there's a certain law of averages to how many times, what kind of rolls you can get. Oh, wow, that's just so insightful. Not. Did you cover electromagnetic waves yet in Walter Lowen's lectures? Yeah, we're heading for it. So the point is, I'm right on the one where he's doing the summation of, here we have gone over the 5 Maxwell equations. And the joke is, waves haven't been touched at all. So there's been no conversation. So he's got isolated all 5 of the equations. We've gone through how they apply, and no waves at all in any of the lectures. A little bit of frequency, but no waves at all. And so that, it's just so ironic because people associate Maxwell's equations with all this wave crap. Now they can be used to do wave mechanics, because wave mechanics is really just saying on, off, on, off, on, off. So obviously you can use Maxwell's equations for on this direction, on, off this direction, on this direction, off that direction. You can do that. But I'm just saying waves doesn't come up at all. So the primary function of these equations don't require any wave nonsense. None at all. To explain the equations and what they relate to. No waves required.
It might just be mathematical fantasies with no basis in reality.
Well, I have bad news for the skeptics. Since the late 1950s.
Well, again, apparently the electromagnetic waves are derived from Maxwell's equations. Well, I'm just saying that, of course, Maxwell's equations contain, the whatever they call it, those stupid mu things, mu 0 and epsilon 0 and mu 0 or whatever, and then you add those two, you combine those two numbers, and it ends up being the speed of light. There's lots of things built into Maxwell's equations that provide the fodder for some other thing. But I'm just saying, the idea, you're not going to derive anything from Maxwell's equations except that these are force laws. All right, and when you turn the force on and off, there'll be that there's going to have a consequence. But that's all it really is. It's just frequency. There's no waves needed. You don't need to wave any of this stuff. It's all just frequencies. It's all just a wavelength, a period. They're ray equations just as more than they're wave equations.
Direct evidence that empty space isn't in the slightest bit empty, but is in fact seething with activity, has been observed time and time again in laboratories.
Again, just horseshit. No, there's no laboratory where you take a bottle of empty space and you find it seething with something. That's crap. complete crap. And these people are so stupid, right? Because they're saying, okay, empty space is seething with something, and yet photons travel billions of light years without getting consumed by the seething. And yet they're too stupid to figure out that, well, what would happen if there were a few atoms in the way, a few stray hydrogen atoms along the way? What would happen if a photon hits a hydrogen atom? You know, would it maybe redshift the photon? Yeah, maybe. Or what if a photon was coming from a galaxy that was expanding, or had a few supernovas in it, and there was a little bit of gas, you know, hydrogen left over, you know, in a gaseous form, just, you know, clouds, so to speak. And the light had to travel through those clouds. Well, maybe you could get a speed number that would seem insane. It's going incredibly fast, running away from us at incredible speed. Yet none of that's true. It's just that the light had to go through a bunch of hydrogen atoms, and they got redshifted. I did hit the button. Not working. I really hate that.
Quantum electrodynamics is by any measure a truly magnificent discovery.
So again, it is by any measure a magnificent discovery. Again, all it's really saying is, oh yeah, there's this thing where, you know, if you shave a little thickness off the surface of something, it changes the reflective index. So you can surfaces are weird and have a probabilistic nature to them, surfaces. What else is it saying? And they're basically just saying it's not for any other reason than just gross randomness. That's it. There's not a physical reason why it's happening. Just randomness.
It's one great pinnacle of our story, a glorious conclusion to 5 amazing decades of science. In quantum electrodynamics,
again, 5 amazing decades in science. The 5 amazing decades from what? 1880 to 1930? Get real. Not even close to amazing.
The atom had given us a theory that explains much of our universe with stunning accuracy.
So again, stunning accuracy. Where's your stunning accuracy? Where's your volumes of evidence? Where is any of this stuff? They don't have any of this stunning. They don't have like a brontosaurus skeleton. They don't have a DNA molecule. They don't have any weight to their evidence at all. And here they call it stunning amounts of evidence. Just amazing amounts of evidence. It's proven itself over and over. In what? In a mathematical equation that nobody ever applies to a physical reality. It's just pathetic rhetoric.
Quantum electrodynamics' triumphant arrival in the late 40s.
Triumphant arrival. I mean, again, just talk. Not anything about how this really did answer a question. It didn't answer any questions.
Our story becomes rather messy and awkward. As a result of quantum electrodynamics, scientists were convinced that the vast majority of everything in the universe consisted of essentially just 2 things, atoms and light.
Well, that's correct. And they should have just stayed with that. That's all there really is. There's, well, light in the many forms of, gravity and magnetism. Stuff moving the speed of light and stuff not moving the speed of light. That's what the universe is made out of. Stuff moving the speed of light and everything else.
Light was made out of tiny particles called photons, and atoms were made out of 3 components, the electron, the proton, and the neutron.
Again, neutron is irrelevant just because we kind of know a neutron is in a proton and an electron. That's what it falls apart into. So why pretend that's elemental? We know that's not elemental, so screw that.
And because of antimatter, there were antiprotons, antineutrons, and positrons.
Yeah, it's all that just made up mumbo jumbo. They play no role. They don't do anything except once in a while you shoot an electron through a piece of lead and it pops out the other side as some sort of anti-electron. But it's really just a proton.
A bit strange, but pleasingly symmetrical.
There's nothing symmetrical about antimatter. annihilations that aren't really annihilations and creating something out of nothing. There's nothing. That has no continuity or reasonableness. Anybody with any kind of brain has got to be saying, no, you can't make something out of nothing. And if it annihilates, that's breaking conservation laws. So that doesn't make any sense.
The physics garden was rosy, thanks to the rules of quantum electrodynamics. But then...
It's not even close to any of that happening. It's just that a bunch of mathematicians took control of physics. And because everything was inaccessible in any direct way, and there was no direct evidence that you could use to say that's bullshit, everybody just had to accept this notion that, look, we have an equation and it seems to work. So therefore, we can say anything about causes.
The profound irritation of every working physicist, a load of new and exotic particles suddenly appeared like party gatecrashers to spoil the fun. Exotic entities that didn't fit into any known theories were appearing in physics labs with such frequency that scientists couldn't keep up with them.
They weren't showing up in any labs anywhere. They were showing up in one kind of lab, and they were showing up for so brief an amount of time that nobody could take it seriously that these were particles that played a role besides being part of something else. They obviously aren't themselves doing anything as themselves. They're doing something as a tire on a car.
The neutrino, the positive pion, the negative pion, the kaon, the lambda, the delta. And of course, each of these had their antimatter counterparts. When one new particle named the muon was discovered, one physicist quipped, "Who ordered that?" The whole thing was a mess that didn't make sense. And physicists despairingly referred to it as the particle zoo.
Right, which in all it really is that these elementary particles can clump under certain circumstances. So if you impose enough energy or you put them in a certain circumstance, they'll clump in certain ways, and then you'll call them something else. When really it's just like the neutron. For a long time, we thought the neutron was its own little something. And then they find out, well, no, you can decompose one of these things in 15 minutes and you'll end up with a proton and an electron. So, yeah, we decomposed it into something more elemental. But the problem is in decomposing the neutron, you get something that is durable. You don't get something that lasts a millisecond.
It began to seem as though every time scientists solved...
So I just explained that force could look like something. See, if we don't have detectors that can tell the difference whether it's getting hit by, the thing, or the force pushing the thing. You can't really tell the difference between, on this small scale, the thing getting pushed, something that might have mass, and the force itself.
One of nature's mysteries, the atom would present them with something even more weird. Within just a few years, atomic physics had gone from a position of quiet confidence to total chaos. And of course, to make some sense of this new mystery would require, yes, you've guessed it, another scientific revolution.
A revolution. So I wonder what this was. Dirac's wacky equations.
The third genius in our story is Murray Gell-Mann. Gell-Mann was a child prodigy. By the age of 15, he'd already started at Yale to study physics and had finished his PhD by his early 20s. He had an incredible intelligence that terrified those around him. He spoke many languages and seemed to have this deep knowledge of any subject you care to throw at him. Like Richard Feynman, whom he joined here at Caltech in the early 60s, he seemed to have this ability to see beyond the mathematics and the formalism of his theories to the underlying secrets of nature below. Together, Gell-Mann...
I don't think so. Idiot savant.
And Feynman made an awesome duo. This office, number 456, used to belong to Feynman. What's great is that just 2 doors along the corridor was the office of Murray Gell-Mann. There was an intense academic rivalry between these 2 intellectual giants, but they fed off each other's creativity. They were very different personalities. Feynman, who played the buffoon, Gell-Mann, the cultured elitist. Gell-Mann used to get upset by Feynman's loud voice, and Feynman certainly enjoyed winding him up. But it's fair to say that during the 1960s and 70s, These two geniuses here at Caltech dominated the world of particle physics.
Yeah, I don't know. You don't see a bunch of Gell-Mann lectures, and you certainly don't see much. I don't see much.
Their bitter rivalry pushed them both to the very limits of their imaginations. And Gell-Mann especially was desperate to prove himself over Feynman by bringing some order into the particle zoo. Within the feverishly intellectual atmosphere of Caltech, Gell-Mann's mind did something very strange. He started working with a different kind of mathematics to deal with the preponderance of subatomic particles. He used an obscure form of maths called group theory. As its name suggests, this is a theory that analyzes groups of numbers and symbols and tries to organize them into simple patterns and symmetries. It's a bit like working with an abstract form of origami. Using this technique, Gell-Mann started working all known particles into an organized system, which he called the Eightfold Way, after a Buddhist poem. But then he had his most awesome revelation.
Yeah, it's just horrible. I mean, you just listen to this stuff and you just go, come on. Oh, I'm named after Buddhism. Yeah, great. Physics. Name it after Buddhism. They use all this stupid, crappy delta, muon, trions, pions. They use all this silly language to describe this stuff. It doesn't have any kind of, it's not even as, electron, proton, it's got some kind of meaning to it. But nothing like that. This stupid thing isn't charging. And so I'm going to mess with it a little bit. And sorry, distracted. Every day is a rough day here lately. There it goes. All right. So on we go.
Gell-Mann realized that his group theory pointed to a new, deeper underlying mathematical truth, something which had the potential of rewriting the atomic rulebook. What Gell-Mann's mathematics revealed to him was that in order to make coherent patterns of all the new particles in his Eightfold Way, he had to acknowledge that there was a deeper underlying fundamental reality. Once again, it turned out that things were not at all as they seemed.
All this.
Physicists have been comfortable with the notion.
It's just, like I said, they just pile on top of their complexity, more complexity. And then they call it, oh, look, we simplified.
That atoms are made up of three different kinds of particles. Electrons orbiting around the outside of a nucleus itself made up of protons and neutrons. Gell-Mann had the temerity to suggest that protons and neutrons were themselves composed of more elementary particles, particles that he called quarks.
Totally meaningless in so many respects. It just can't. You can't be bothered because the quarks don't do anything but create electrons. They don't do anything else. They don't quark around. They don't quark between electrons and protons. They don't quark over here and they don't quark over there. They don't quark anywhere. They're totally non-essential to understand them, because the only time they do anything, like the only time a car means something, is when it's moving down the road or something. Identifying what it is when it's not carring doesn't mean much. It doesn't mean anything.
Gell-Mann was cultured and arrogant, but at heart lacked confidence. He knew that for his colleagues, even those used to the strangeness of the atom, quarks were a step too far. And in any case, there'd been no evidence of anything remotely like a quark. He was convinced his new theory would be declared outlandish, or just wrong. So Gell-Mann sat on his revelation, and one of the greatest ideas in science was almost lost forever. Then something extraordinary turned up just a few hundred miles north of his office.
This is just a story told, right? We have no idea exactly how much his mathematical prediction matches exactly what they found. We are never going to be told exactly how much that matches.
This is the Stanford Linear Accelerator, a few miles south of San Francisco. What you can see below me is one end of what is basically a giant electron gun. A beam of high-energy electrons is fired through a tunnel that starts off over 2 miles away in the hills. It travels underneath the freeway and comes out at this end where it enters the experimental area. The grey building over there is called End Station A, and is where one of the most important discoveries in physics was made. It was built during the 19th.
So most important discoveries in physics. You're just saying, why? It seems an insane exaggeration. You know.
1960s, when it was, and still is today, the longest single building on Earth. And although it's 40 years old, you can see a lot of construction work is going on now, but it's still being used for fundamental research today. I'm now inside the 2-mile-long linear accelerator building. The red objects you see on your right are called klystrons, and they provide the power that boosts the electron beam that runs 20 feet beneath us. Such as the acceleration, these electrons will, within the first few meters, have reached 99% speed of light.
Right. Say they, right? Where I would argue that, no, they're not electrons anymore. So, you know, in all probability. But regardless, so he says, it's kind of funny because, yes, he says that they've reached that in the first 20 meters or whatever it was. And you're just saying, well, then that's as fast as you're going to get them going. So why even shoot them all to 2 miles for? Because they're not going to be going any faster.
Let me put it another way. If these electrons were to start off their journey at the same time that you fire a bullet from a gun, they would have covered the full 2-mile distance before the bullet has even left the barrel.
Yes, electrons are smaller than bullets, and they go farther and faster, but they only go while you're pushing them. So you have to continually push them. So they push them with a tremendous amount of voltage, and then they smash that voltage into a target. You know, I don't even think the electrons matter once you hit them with the voltage that's behind the electrons.
The electron beam, now traveling at almost the speed of light, would have arrived here at the target area. There would have been in 1968, where I'm standing now, a large tank of hydrogen, basically protons. The electrons would smash into the protons and scatter off through tubes to be picked up by huge detectors that filled the hall outside. And as they did this, physicists got their biggest ever confirmation.
All right, so at least we're going to see maybe the big image of the. Oh yeah, that's right. They don't have an image of a quark.
That there might be a deeper set of rules underpinning the particle zoo. What they discovered from the way the electrons scattered and because of their extremely.
Now, why is it doing that? The echo. Where'd that come from?
High energy was conclusive proof that protons have internal structure. In other words, protons.
So conclusive proof, we didn't see any of that, right? So we just see the hardware, we just see the blah, blah, blah. We don't see anything like the proof argument of any of it. So no proof provided, just the statement that we proved it.
Themselves made of more elementary particles. Here were Gell-Mann's quarks.
Now, there's just no evidence of where these quarks are, or what things they're calling a quark. Nothing. No insight into why we should believe it's a quark. Nothing.
This was an astonishing moment. For decades, people were confident that the components of the atomic nucleus, the proton and neutron, were absolutely fundamental. And now, for the first time, there was evidence of something deeper.
Something deeper, meaning they broke the proton, which is big, into pieces. And, you know, they can call it up, down, left, right, whatever they want to call the pieces, because the pieces move in a particular way. When you explode something, it explodes forward and left and right, and those are going to have different velocities, right? If you crash into something, you sort of understand the stuff moving this way is going to be slower than the stuff moving this way. And so they identified the little bits of crap that blow off this way as up. And this is, you know, left and right, and then it's strange, the little pieces that go this way. You know, just horse shit.
The quark is a tricky and elusive beast. There are 6 different kinds or flavors of quark: up, down, strange, charm, top, and bottom.
Right, and they just have to do, in my opinion, okay, with fender went forward, you know, wheel went to left, you know, steering wheel went up. You know, you can almost say 6 dimensions, right? So it's kind of funny, right? They have the six dimensions, right? I mean, 6 subdimensions: up, down, left, right, forward, back. Oh, and back would be definitely strange.
Also, quarks never exist in isolation, only in combination with other quarks. This makes them impossible to
Yes, well, obviously, if you're blowing the wheels off, then the rest of the hood has to go somewhere, and everything else has to go somewhere too. So that's right. When you blow the car up, the different parts go different places. Yes, and they all have to go. Some of them won't stay. So when you blow something up, yes, you blow it all up.
See directly, we can only infer their presence. But despite these caveats, the quark...
Yes, some caveat. We can only infer their existence. So no explanation, the hard evidence, the proof. He proved it, right? With infer. We can only infer, but we proved it with our inferations. Yeah, we proved it.
Brought some semblance of order to the particle zoo. In recent years, it's allowed us to concoct a simple yet powerful...
Concoct is just such a great word. It's just, that's all it is. A concoction, a bunch of crap just spilled, thrown together, and you've glued it together with a bunch of bullshit. Imaginary particles that you didn't even find any evidence of, but you just created them because they work. Like the dark matter.
Description of how the universe is built up. Basically, everything in the universe made of atoms is built up from just quarks and electrons. That's it.
So again, it's just reducing the proton to its to say it. Yes, we could surmise that protons are big and electrons are small in terms of mass. That doesn't mean size. Electrons could be bigger, just like gaseous planets and stuff. You know, they could be big but not as dense, and protons could be small and very dense. I mean, you know, there could be lots of rules like that. That's why protons are hard to hit, all that kind of crap. But clearly they have more charge, and clearly that charge relationship has to do with the fact that the electrons are on the outside and the protons are on the inside. So clearly there has to be an equalization of their effect over distance. So the proton, this distance is huge, by the way, you know, the distance the electron is from the proton. Well, they say, but let's assume it's somewhat correct. Then, you know, obviously the charge on this proton has to be a lot stronger to be equal at this distance, because that's technically that keeps the atom from being a monopole or charged all the time. So the only way an atom can be a neutral atom is somehow the distance of the proton has to be the same as the force from this distance of the electron. So by the time the force of the proton gets to here, it's the same in volume. It's been weakened by the inverse square law, and it's the same in volume now as the thing far away. Just like the Earth, in a way, you could say that if you were at a certain distance from the Earth, and the Earth was between you and the sun, that the Earth could have the same pull as the sun, depending, you know, if you move the Earth closer. There's a point where you could be, let's say, the moon's distance from the Earth, if you were stationary, and so the Earth moves and the sun is exposed, and there could be a place in space where the gravitational attraction of the Earth would be exactly equal to the gravitational attraction of the sun. And so I'm just making the point that clearly protons are more than electrons. So if we can say electrons are pretty elemental because it's hard to ever know you ever broke one, well, protons maybe aren't elemental. But again, I don't know why we would call what they're made out of quarks. Why wouldn't we call them the elemental proton. You know.
This now brings us pretty well right up to date. The discovery of the quark in 1967 was the last significant experimental discovery of a new type of fundamental particle. Some say we may yet discover the quark is made of something even stranger, and it's possible. But for now...
Yeah, like I said, it's just all crap. This is just a tiny bit of shreds of evidence, just tiny shreds of real evidence, and it's just all a bunch of speculation. And the irony is it doesn't answer any fundamental questions. It really doesn't answer any fundamental questions. This quark thing does you absolutely no good in understanding how anything works.
It's as good as it gets. Our journey from Einstein's proof of the existence of atoms in 1905 until now has been extraordinary.
Einstein's proof of the existence of atoms? Amazing.
We've learned so much about the atomic world, from the size and shape of the atom to how its center holds the secret of the universe itself.
And so just more stuff. I mean, obviously there's secrets, obviously, and you've gotten wrong. In my opinion, you're just making random guesses, almost random, at what causes the thing to do what it does. But I don't think any of your guesses are very good. They're crappy guesses, and you're clinging to them like they're golden and like they're hugely proven. And all you're doing is saying they're golden and they're hugely proven. You're not proving they were proven.
How it reveals an unknown world of antimatter, to how empty space is far from empty.
Some more crap. I mean, again, empty space is far from empty. Then obviously photons have no excuse for being able to travel 14 billion light years and remain in one piece. It just doesn't make any sense if it's far from empty.
This thought was a basic building block of the universe itself, to the discovery of something even more fundamental inside it. And
again, more fundamental in no interesting way whatsoever, in no way that explains, that gives you any insight into charge, into how electrons and protons interact, into how electrons and electrons interact, why they repel. Doesn't explain anything, really. It's just crap.
Yet, despite all the powerful science which we've uncovered, something doesn't quite add up. There are two startling and worrying anomalies.
Well, the big anomaly is you're not explaining the most fundamental forces in the observable universe, the most fundamental ones. You still don't even know what a photon is. You don't know how magnets attract, and you don't know what makes planets move into suns.
The first of these is now at the forefront of theoretical physics across the world, and it concerns one of the oldest scientific principles there is.
Gravity. Now, though gravity has been thoroughly understood since Einstein, it's never...
Again, thoroughly understood since Einstein. It's just an amazing statement when the description doesn't give you any clarity to cause at all. There's just some magical, spooky action at a distance. That's all it is. I mean, it doesn't say anything. It just says somehow magically anything that has this mass thing sucks empty space. Sucks space. And somehow that matters to planets, and they have to go fill the empty space void. I mean, it's an empty theory, and you ought to just admit it's an ether theory.
Really been part of atomic theory until now. Suddenly, there's a glimmer of hope from ideas that sound almost too crazy to be possible. Some of these are called string theories that regard all subatomic particles as tiny...
Right, and this has nothing to validate it. It shouldn't even be a conversation, and this stupid vibrating strings, the universe is a symphony, and blah, 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 blah. It's all just baby talk.
Vibrating strings that have higher dimensions of space trapped inside them. Some, called brane theories, suggest our entire space and time is just a membrane floating through the multiverse. Another, called quantum loop gravity, suggests that nothing really exists at all.
Oh yeah, so suggest that nothing really exists at all. I mean, it's just, this is what people who have some kind of intelligence, this is the conversation they have about our reality. I mean, this is just so depressing. I mean, what a just disgusting waste to be talking this rubbish, this religious rubbish.
Everything is ultimately made up of tiny loops in space and time themselves.
But despite gravity's unwillingness to fit in with quantum theory, I believe there's something worse lurking in the quantum shadows. Something truly nightmarish.
I believe.
Lent into the night at physics conferences all over the world, over drinks at the bar, when we scientists huddled together to debate and discuss our strangest ideas.
Yeah, that's right. I don't think you debate anything. I don't think you do anything called having a rational conversation, because the conversations you start with, wow, we've really just been jerking off for 100 years, haven't we? Is where we're not explaining anything. We're not explaining why anything happens here at all.
And dreams. There are still things that really, really bother us. And chief among these are the quantum mechanical laws that atoms obey. And in particular, one aspect of these laws, something called the measurement problem.
Oh, it's amazing that he's going to bring this up when it's just such an obvious, there's no solution to the problem. The ruler runs out eventually. You don't have anything smaller to measure anything against. You don't have something small enough to measure. I mean, it's such an obvious problem. It's an obvious problem. You can't bounce light off of light. You can't disturb something. You can't measure something with something bigger than it is, the thing you're measuring.
If you want to see fear in a quantum physicist's eyes, just mention the words, the measurement problem. The measurement problem is this: an atom only appears in a particular place if you measure it. In other words, an atom is spread out.
This is just such a perversion of the words measurement problem. I mean, clearly, Brownian motion's been known forever. There's nothing complicated about the fact that position is ambiguous from our detection, because the thing is moving insanely fast, jittering, and yeah, we have no tool to see that. So all we see is an average. But we have the averages. Amazing. Wise monkey. Hey, Gary. Have a blast. I don't know what that means, but whatever. Your personality disorder is not a philosophy. Oh, well, this is, I'm not going to read your comments. How about that? So you just wasted all that typing. Ha 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 ha. Way to go. Jeez. I mean, you can't even grow up a little bit. Just a little tiny bit.
Out all over the place until a conscious observer decides to look at it. So the act of measurement or observation creates the entire universe.
So he says this is something they really ponder over. Like, this is something that, oh yeah, well, if we're not here to observe it, it didn't happen. Because we're so fucking important. Observation is all there is. Blah, 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 blah. Something doesn't crash in. So if the meteor heads for the Earth and it has a choice to just disappear or hit the Earth. No, it's going to hit it. That's what it was going to do. It was doing it right from the beginning. It's the photons coming 14 billion light years away. They're heading right for us. There's no doubt about it, what's going to happen. They're doing their thing the whole trip. I mean, somebody thinks this is complicated. They really think the bullet isn't a bullet until it hits you in the head. It's just so fucking stupid. Why would anybody find that ponderous, or, oh, how can I solve or resolve this terrible problem of the measurement problem, that somehow something isn't something until it hits something else, when I can only see it when it hits something. I mean, obviously you can't see the photons when they're moving, but we're all like smart enough to say, oh yeah, I know it's still there. Okay, yeah, I know it. You don't see the Kennedy bullet, right? You can watch this computer film. You don't see the bullet. But you know it hit the target, okay? And you know it was in the air, and you know it fired from the gun. I mean, there's no complication here. You're not worried that the bullet was a magic bullet, are you? Well, actually, no. But obviously, if you're a scientist, you understand.
And just to show you how mad this idea is, I'm going to explain one of the most famous hypothetical experiments in the whole of science.
Okay, here we go. This is, the most famous hypothetical experiment. Great waste of time. Schrodinger cat. I mean, just so stupid. Like this, this has any logical person would say that physics doesn't take place because I closed the lid on the box. So I closed the lid, and all of a sudden now real physics isn't happening anymore. There's time isn't happening in there. I closed the lid, time doesn't happen, nothing happens at a regular interval, no things really happen, and it's not until I open this stupid box that some kind of reality will happen. So inside the box, it's not dark, the cat isn't still breathing, nothing's happening. I mean, it's just an insanely stupid thought experiment. It shouldn't take any thought to say this is just a stupid thing to even ponder. Why don't I just imagine that there's hoobies, living on the surface of my anus or something? What's the point of it?
It's called the Schrodinger's cat experiment. Erwin Schrödinger was one of the founding fathers of atomic theory, and in the mid-1930s devised a thought experiment purely to highlight the absurdity of quantum mechanics. He suggested you take a box in which you...
Yeah, and it's absurd. It's just an absurd nonsense that somehow physics doesn't take place until the end result. Like nothing travels when we know there's a speed limit, when we know that things travel, we know all this stuff happens. So why are we pretending that anything's in an ambiguous state or a non-existent state? Clearly, just because you can't measure where a photon is, in the sense you can't measure its momentum and its direction without destroying it, without interfering with it catastrophically, why is that cause to create this fake notion that the thing doesn't have a position? I mean, it's just such baby talk that somehow it won't decide where it's going until it gets there. I mean, why would an intelligence say that that's the right answer? I mean, that's just a silly answer.
Place an unopened container of cyanide connected to a radiation detector and some radioactive material. Now, the idea is that if an atom in the material emits a particle, this can be picked up by the detector, which in turn releases the cyanide.
I mean, why do you bother saying a particle when you think it's all wavicles?
Next, you take Schrodinger's cat, which in this case is a lovely Norwegian forest cat called Dawkins. Now, I should point out that this isn't real cyanide. You place the cat in the box, you close the lid, and wait. So here's the conundrum. According to traditional quantum mechanics, known as the Copenhagen interpretation, all the time the box is closed, the radioactive atom inside has yet to make up its mind whether it's decayed and spat out a particle. So we have to describe it as both having decayed and not decayed at the same time.
You have to, for some bizarre, just unimaginable to me reason, that you would waste your time with the most inane of answers to the puzzle.
Think about what this means. Since the radioactive particle triggers the release of the poison, the cat is both poisoned and not poisoned. So until we open the lid to check up on the fate of the cat, what's called making a measurement, it's not just that we don't know, but that the cat is literally both dead and alive.
Right. It's just bullshit. Again, there's nothing to do with it. It's just idiotic to think that you couldn't just put a device in there that also rang a bell the minute the radioactive thing went off, or some other mechanical thing that points out that the event has now taken place. But it's going to take place. The mechanical rules of the universe don't stop because you closed a box lid. This box lid prevents the universe from getting in there. The laws of the universe can't get in to the box. Yeah, they can.
At the same time. This is clearly a paradox, or is it?
It's clearly retarded.
The paradox of Schrodinger's cat and the contradictory nature of the measurement problem really does force us to accept that
I mean, look, what should be accepted is that it's a perfectly good way to point out how silly what you're saying is. It's saying it's silly. You can't prevent reality because you closed the lid on a box. You haven't stopped the process of the universe. It's just stupid. Yes, and they just say, no, we're going to pretend it's not stupid, even though you pointed out how stupid it is.
tiny objects down at the atomic scale obey their own set of profoundly strange rules.
Says you again. They're going to be incredibly simple rules, and you idiots are just too stupid to figure out that, oh yes, I'm supposed to find the simple things, not do this fantasizing about all kind of Alice in Wonderland bullshit. I'm supposed to be drawing a picture of reality, not drawing a picture of a fake world. Oh, shit.
But at larger scales, those of everyday human experience, those rules vanish, and an utterly new set of nice, intuitive rules take over. How can this be? Some argue that, in fact, the quantum weirdness of the atom might actually be...
There's no quantum weirdness. Again, the fact that everything's a weirdness. So the two-slit experiment, it's a weirdness. The shaving off the surfaces of glass, it's a weirdness. The Brewster angle, it's a weird. No, they're not weird. They're just things you can't physically explain because you have no mechanical model. But they're really simple things. They're not very complicated. I mean, the light changing the angle by exactly the same number of degrees. That's not very complicated. The reflective index changing from 16% to 0 and cycling through that pattern. Well, that's not all that bizarre and strange. It's not that complicated. And here you are coming up with these bizarre reasons.
Writ large across the cosmos, that we may have to rethink everything we knew about the universe. In the last 100 years, we have peered deep inside the atom, the basic building block of...
Yeah, whatever. You've inferred deep inside the atom, as you acknowledged. We have to infer their existence. Can't see it. Oh God. This is where if someone with your attitude responded to you, they'd rant for 20 minutes about how you are misparaphrasing. Well, I'm not misparaphrasing. I'm playing the fucking argument. God, I mean, you people are just so lame and so weak. I physically play his exaggerations. I emphasize clearly the words he used. We have to infer their existence. We have absolute proof. How have I misparaphrased him? It's the most proven thing in the universe. It isn't. Okay, argument and are guilty of slander and libel. Well, just more bullshit. Okay, and bunghole name, you're going to get blocked just for that. I mean, what are you, 12, 13? What is your problem? God. You think, oh, here comes a respectable comment from somebody who calls himself bunghole. Amazing.
Universe. And inside this tiny object, we have found a strange new world, governed by exotic laws that at times...
So they found it, and they, this idea, like I said, that, like this was discovered through the volume of evidence like Darwin presented. Volumes of evidence going through bird beaks and turtle shells and sheep and pigeons and oysters and other, whatever, barnacles. He studied barnacles for like 10 years. All kinds of things to collect a whole pile of evidence. And they're going to compare this slop to that?
Seem to defy reason. Atoms.
Yeah, defies logical credulity. It is an incredible story you're presenting as the reality based on these shreds of evidence, just tiniest of shreds of indication of an irregularity or something a little bit mysterious, like the two-slit experiment. And instead of grasping the logic of saying, well, what's the more complex thing here? The surface the photon is moving next to, or the photon? Which one likely has the ability to make things happen? The thing that always goes in a straight line for 14 billion years at exactly the same speed, or this surface stuff that's cluttered with billions of atoms? Which one is more likely to be the cause of the effect? Duh. And that's a hard question for you fellas. And you got the wrong answer, which is even more amazing.
Present us with dizzying contradictions. They can behave both as particles.
Now again, they don't do any of that, behaving as both, or you get to pick, or any of that crap. There's certain evidence about what we can say about them. They move in a straight line. They move the speed of light. They have a certain momentum that they can transfer. That's it. And yeah, they can't be bent by magnetism. They can't be bent by electricity. And so there's absolutely no reason to think they get bent by gravity either. And obviously the experiments demonstrate they get bent by gravity suck. And they have a frequency, and the frequency can be changed, like redshift, and it's changed for reasons. But they're also transmitted through materials, and they seem to move slower through materials, but you can logically understand that, oh yeah, like a fiber optic cable, they're really not moving slower, they're just traveling a longer distance. Dear. I mean, easy answers to these puzzles, and you people just couldn't give a shit about the easy answer. You just will not answer the question. You got a choice, A, B, C, or frog pie. And you're just not getting it. It's A, B, or C. It's not frog pie.
Waves. They appear to be in more than one place at the same time.
No, they don't. They really don't do any of that. So that's just, again, where do you have even a slightest piece of evidence that anything appears to be in the same place at the same time? Where's one shred of evidence that a photon ever appears to be in the same place at the same time? Bullshit.
Force us to rethink what we mean by past and future, by cause and effect.
Yeah, no problem at all. Past and future are all quite reliable. There's no evidence that you've even gone 1 millisecond into the future or 1 millisecond into the past. They're just the consequence of things moving a distance at a velocity. If everything happened instantaneously, no universe, no worries. But clearly that's not the speed of the universe. So there's a thing called time, not mysterious. It's used up. And all there really is past and future, because the present isn't really even a thing. It's gone so fast.
And they tell us strange things about where the universe came from and where it's going.
More horseshit. And then quantum mechanics says nothing on that subject. Doesn't provide any insight at all. It's just such horseshit.
Pretty amazing stuff for something that's just a millionth of a millimeter across. That's why Niels Bohr, the father of atomic physics, once said that when it comes to atoms, language can only be used as poetry.
So this is the founder of their bullshit. Language can only be used as poetry. We can't figure out any real words like up, down, left, right, forward, back. We can't. Nothing's solid. Nothing's real. Oh, man, amazing. This really is just a religion, the Bohr religion. Boring Bohr. Just so frickin' dim-witted.
What's fascinating to me is that although we've learned an incredible amount about atoms and their behavior, our scientific journey...
You haven't really learned anything, quite obviously. You have no clues how anything fundamental happens. You're still clueless about what makes a photon, how it interacts, what the real nature of reflection is, what the photon is bouncing off of. You don't have anything, because it doesn't really do any of this bouncing off, and it really is always an absorption and a readmission, and you're just so clueless.
It's only just begun, because although we know how a single atom or just a few atoms behave,
the way trillions of them come together in concert to create the world around us is still largely a mystery.
And again, it shouldn't be, because the obvious force doing that is that magnetic thing, the charge thing, the fact that there's two different things and they're creating enough of a difference between them to create a low pressure that causes this condensation to happen. And the only way it can happen is because the whole universe is pressurized, and that's gravity. And you can convert the gravity into magnetism, you can convert it into an electromotive force.
To give you one dramatic example, the atoms that make up my body are identical to the atoms in the rocks, the trees, the air, even the stars. And yet they come together to create a conscious being who can ask the question, what is an atom?
Again, and that has nothing to do with this subject at all. But clearly, that's called evolution. Hundreds of millions of years of biological system evolution through the use of the DNA molecule and all that crap. I mean, I shouldn't have to explain to you why we're different than a planet. Fuck. In philosophical terms, this is classic idealism. I don't know where this keeps this idealism word. I never even saw this idealism word a year ago. And all of a sudden now everybody just keeps saying idealism versus materialism. This is just such bullshit. There's nothing ideal about making up fables. They're not talking about anything ideal. They're not making an ideal universe or any of that kind of notion. It's just plain nonsense. It's drivel. Idealism is the idea that concrete or reality is false. Again, it's just why? There's no evidence of that falsehood, and just a reflection of the world of absolute ideas. Well, there's no such thing as an absolute idea. Ideas are specific things. They don't have any absolute shape or size. There's no infinite idea. Ideas are confined, pen, brown. They're confined. They're the exact opposite of an absolute. They're so narrow. That's the whole point of having the word, is to say brown. That means not blue, not red, not green, not this, not that. It's brown. I mean, fuck. This dominating modern mainstream science, I don't even know what that means. More crap. Is to define a false authority built on laziness and rejecting things that they don't come to understand. Well, whatever. Now we're going to have to argue about the cause of why these people are talking fucktards. Why they fell for fucktarded. Well, they fell for it because we're too impatient is the fundamental answer, right? We sat here since Newton, right? Newton didn't explain gravity. They don't have a good theory. So nobody came up with a good theory. And they were so confused that they even forgot in 1801 when Young does this stupid slit experiment that Newton already did these experiments. He already took a hair and created the bar pattern. He'd already done it. It's no big surprise. It's no big news. And they're so disconnected from their physics because they really don't have any answers that they fell for this notion that somehow Young did something incredible. He didn't do anything incredible at all. He didn't do anything Newton hadn't already done. And that's how lame this whole bullshit is that, two slits and two waves and Huygens. And then they had to find out, oh, wait a minute, a single slit does the same thing. Well, let's only show it when it's making little tiny lumps. Let's not show it when it makes a whole bunch of bars because that'll make us look like idiots. So then so it's just they bought onto something, they clung to it, and now they're just trying to make it, reconstruct it, and force it to work by creating a bunch of convoluted mathematics and abstractions, where they cut the speed of light into two different constants, 2.7 times 1.4 to make 3.75 whatever meters per million meters per second. So it's just all contrived shit. But why do they do it? Is because there was no competing theory that worked. There was no mechanical model that could it could explain why this attraction force and why the system worked the way it is. But they didn't look hard for it. They just weren't. I'm sorry. They didn't. It didn't. You know, like I said, Feynman was close because he said, "Look, it's probably a checkerboard with really simple rules, and we're just being fooled by the huge volume of it into thinking it's doing something more complex than it really is." So he had the notion that the underlying principles have to be simple, but they just didn't fall on the simple fact that all you have to do is to have a positive to match your positive and negative material charged bits. You just need to take the force and make it charged bits too, and then you're won. You're done. You can explain everything. But the reason why they're talking this shit is because they didn't have a better model, and that's it. Because it's all stuff that's happening in a very hard place to see. All right. Anyway, science moves through a paradigm shift. Oh, I hate this rhetoric. God, I just hate this kind of talk. This is paradigm shift. It's just such a pile of shit. There was no paradigm shifts. I mean, hundreds of years. Like I said, from 1801 to 1930, they had no clue. And through contradictions such as this, well, whatever. If we as human society were to move forward in understanding our universe, oh, fuck. The physicists aren't doing it yet. So why are you talking about human society? Then these mainstream mystical and magical physics must be overthrown. Well, the point is the intellectuals have to grow some intellectual balls and be more like Newton and say, I don't know. Because these assholes don't have the integrity to say, no, we're really clueless and we're jumping and we're leaping way ahead of the evidence. We get a tiny shred of evidence and we jump to frickin' bizarre conclusions. We can make black holes crash into each other. We can do all kinds of shit on a shred of fucking evidence. And that's really crappy science. Okay, when was the last time you actually had a live conversation with somebody who could refute your straw man BS in real time? I've invited them, idiot. So that's all I can say. Why don't one of you ball up and show up? That wasn't limited to 200 characters and didn't end with a cutting them off. I didn't cut you off. And your characters are kind of useless because you don't make any real arguments. You just keep using words like paradigm shift and idealism versus blah, blah, blah. Well, no, you're a different asshole. Hypocrisy much. Yeah, same douchebag. Fake name again. So fuck off. I mean, if you can't, at least title yourself something totally benign, and I might read your comment, but I'm not going to accept your crap as a fucking title. Your obvious sock account. Fuck you. All right. Oh, fuck. Let's see, move forward. Okay, so here we got more paradigm shift crap. Paradigm shift, Thomas S. Kahn explained it beautifully. Well, it says you in the structure of the scientific revolutions. Yeah, fine, whatever. You have your little Bible too. There is a clear reason for these mystical science dominating the mainstream narratives. Well, too bad you can't make the clear reason. You can't just articulate that. What's the clear reason? How many months for the contest? Give a specific number. Well, you're kind of an idiot because you really don't understand how the contest works. You can't pick people who haven't died yet, like in a dead pool. Right? You can't say, okay, let's do a dead pool. Who's going to die first and second, third, fourth, and fifth? Okay, but yeah, let's end the contest in a week. Okay, so yeah, pick the dead pool, and yeah, nobody's on the list yet. Nobody died in a week. God, people are just fucking revolting. I just don't know. See, you could actually take all the names and put them in order, you see, and just for curiosity, see how many of them you get right. All the names. Okay, but the point is the contest ends when 11 of the names have died. 11 of the names have grown integrity and are going to admit the fundamental truth, which is my theory works. You said it'd be over in a few months somewhere. I didn't say, never said any such thing. Dream on. Didn't happen. Said you might hope that it would be. Maybe I said something like, well, we could hope, but we know it's probably not going to happen. Here we go. You're so confident. Why would I end up trying to predict when idiots are going to not be idiots? What does that have to do with the subject of physics? I say I know physics. I didn't say I know how to predict what human psychology's, when is the person with a small dick going to get over having a small dick? I don't know. Oh, fuck. Human interaction is just such a waste of time. No offense. To the exceptions. There are exceptions. But not too many. Sad world we live in. Of course, there is an economic and political reason. So again, it's this conspiracy theory mush. These people go to college, they learn this stuff, they admire their professors. They say, oh, my professor can't be full of shit. And they just fall for it. It's a religion, and they fall for it. They're not sitting here doing this for political and economic reasons, saying, oh, I'm going to lie to people for political and economic reasons. No, they actually are so invested in this nonsense, they haven't taken their blinders off and looked at the facts. This guy doesn't even know how the two-slit experiment works. He sat in a tuxedo in a video I played, explained the two-slit experiment completely inaccurately. So he hasn't even done it. He hasn't even done hands-on, played with these things and saw the effects and tried to manipulate them and see what he could make the thing do. So they are just totally invested in their bullshit, and they haven't really physically looked at the evidence. I mean, I saw this in a there's a few things that need explaining, in some of the future Professor Lewin videos. But there's a point in one of them when he's doing light separations, right? And it seemed to me, I think it's a diffraction gradient or something, and it's very curious because the light, the center one is white, and when you shoot white light, and then you have blue, and then you have red. And the weird part is that we know the frequency of the blue has to be somewhere around 350, 400 kind of maximum before you start turning green, right? And then you have the red. That's got to be, somewhere around 700, right? So they're almost half of each other, right? The blue is almost half the frequency, as the red. And that sort of fits because, when you go 3 out, they almost are on top of each other. But when you look at the mathematics, right, the mathematics doesn't fit what you actually see. Because when you actually look at it, the blue is way out. The white is here, the blue is here, and the red's right next to it. Now, that's not the way it's supposed to be, right? I mean, the blue is supposed to be over here, not over here. So I'm just saying little things like that are indications that maybe this isn't, this bullshit is just that bullshit. Just like when I point out that the single slit, you get these bars of light, and it's not doing the gradual wave thing it's supposed to be doing. The light isn't going gradually on and gradually off. It's going pretty sharply on and pretty sharply off. So there's lots of indications that this is not the solid theory they present it as. And as I've shown in these experiments, that's all how they do the experiment. Like when they put the aluminum ring on the magnet, and they have a slit cut in it. They don't show you, well, what happens if we make the slit really wide, or what happens if we make the slit tiny, tiny, tiny narrow? What happens if we put a little wire across? You know, they don't show you any of this, you know, because that isn't going to sell their theory. It's going to make their theory look confused. I just played a Professor Lewin video where he's saying paramagnetism creates attraction, when all the experiments indicate that it creates repulsion. I mean, I don't know how that video can be correct. He just keeps talking about how it creates attraction. How can it possibly be doing that? They repeat what they're told. They don't think for themselves. Well, they don't doubt. And that's the key thing, right? Is a little bit of doubt, right? Once you have a little bit of doubt, I had it. You know, in truth, it did take me like 45 years to get around to saying I'm going to look into this hard and see if I can find an answer. But I mean, I always doubted the silly, you know, two-wave particle theory thing, like photons are this complex wave bullshit. But yeah, they don't doubt anything, so they don't go looking for a better answer. A sheet of foil is about 10 million times thicker than an electron, yet these two slit guys like to show it like it's tennis balls going through an open window. And you know, and clearly surfaces show up all over the place as being a complex thing, right? That's all Newton should have really said that word, like surfaces are 90% of this electromagnetic crap. Anything going on with photons and electrons, it's all about surfaces, because it's everywhere. Is surfaces with the diffraction, reflections, diffraction, refraction. It's all about the surfaces and the change in the density of the material. And you know, and then clearly in this two-slit thing, you can't get any more obvious about how you're just making it obvious that this is about surfaces. You know, the single needle, obviously two surfaces. You know, I shouldn't have to, you know, I certainly shouldn't be ridiculed for pointing out something so obvious. Not even close in scale. I don't know what that means exactly. I mean, I don't know how many electrons there are in a sheet of foil, so I guess I don't know whether he's saying the other guy is wrong or what. I don't know what not even close in scale. It's just, you got to say more than that. It's just not enough of a statement. Are you talking to him? You're talking to me? You're talking about what I said 3 minutes ago or 5 minutes ago? I mean, just not very helpful. I don't know what this is. Dostri, I don't even know what it is. Notwithstanding, I don't even know what that is. I don't need to be talking Russian. I got enough problems doing English. And such. These fixed ones, you know, they got a couple of these different ones where you know, whatever that's called. But anyway, for the nicotine, you know, it's a nice thing. You know, it's like a knockoff. But yeah, I knew it was. You could kind of tell because it's not very heavy. it's got a crappy battery in it. So the battery's almost useless now after 2 months. Can't usually post links in the comments. I'm surprised that worked. It's probably not a complete link because it looks broken. Let's see. But I really hate random linking. Really hate it. The problem could easily be caused by electrons striking the edge of the slit in the foil. Why are we talking about foil for? Some go straight through, but tons of them would be refracted. Well, the point is that the surface of materials, obviously there's a mixture zone where with any material, the molecules are moving back and forth between the two materials. So if it's air and glass or air and anything, the atoms actually do fly off of the surface and they bounce off and bounce back in, and there's lots of activity. And when you put two surfaces together close, there's even more activity, in terms of, because they're going to have something in common with each other. And there's going to be charge relationships and all kinds of stuff that's going to make more activity between those surfaces. So it's just so obvious. You're putting a bunch of matter close to a bunch of matter that you would start to get a lot of irregularity in between that surface. That's why you get sparks. That's why electricity jumps the spark, is because there's more activity. There's more activity in the air molecules, and it creates a conductor pathway for the voltage. I mean, shit. This isn't that difficult to have some rational surmising without going off wacky limbs. Now let's see what this stupid link is. No, it didn't work. I guess you have to do something else. Paste the link. And hit the arrow. Okay, hit the arrow. I hate this stupid arrow shit. No, it still didn't work. So the link has to be clicked directly. I can't copy the link. What a pile of crap. YouTube redirect. What a pile of shit. It's such a stupid fucking cunt company, YouTube. The structure of scientific revolutions. Well, isn't that special? You know, I'm sure 5 people have read this horse shit. Really, if you think this means something, this stupid dissection of why people have made mistakes in the past and throughout history, jumping on stupid bandwagons like Christianity or Muslimism or Buddhism or any of these stupid bandwagons. Basic approach. Kahn's approach is the history and philosophy of science focus on conceptual issues like the practice of normal science. Oh, normal science. Let's see what that is. Identified and elaborated on by Thomas Samuel Kahn. So it's his own. He gets to have his own definitions. Normal science is the regular work of scientists theorizing, observing, and experimenting. Well, these are all different things, really. Theory is a lot different than doing experiments, and so whatever. It's normal science. Anyway, whatever. If this stuff floats your boat, fine. I just don't think there's any point in it. I don't think he's going to get to the real subject. One of the aims of science is to find models that will account for many of the observations as possible. Yes, exactly. And the point is, there's no competing theory. So they jumped to a silly answer because they were impatient. So there was no good answer. So they all jumped to a silly answer. And if they thought about it for a while, they could have realized that 300 years ago, more than 300 years ago, Fadio came up with a perfectly rational explanation, and they threw it in the garbage. The Lesage gravity, nuanced into what we modernly know, is an incredibly rich foundation for understanding reality. I mean, particle gravity makes a ton of fucking sense. The pattern could be easily caused by electrons. I did that. Quantum computing is the new bandwagon. Well, I don't think it is, just because there's a tiny amount of investment in it, because most people know it's horseshit. So I don't think it's going anywhere. I mean, it's going to be really hard to come up with anything you can patent, you know, in quantum computing, you know. So it's just there's no way to make money on it, and it's and theoretically it's just mush. And what would they use the quantum computers for? You know, just to do preposterous equivalent. Let's find pi to 10 billion places. You know, they're just going to waste the computer on nonsense anyway. A soda machine can tell you suck, pretty much. You don't need much of a computer to figure out human be asshole. So, okay, well, leaving pretty soon, I think. So, gonna reasonable subjects or questions, or we'll move on. So I can close this stupid window. Now let's go to something more interesting, maybe. I guess I could see what Ken Wheeler's up to, see if he's got any new interesting videos. Theora Papablopoulos. Black wrong. Photoshop fallacies. Whatever. Photoshop. Speed light tricks. Salty rant. Hey Fuji folks. Not much here. Some stupid lens. Don't watch this video. He's doing leather stuff, I guess. Yeah, so this is this double slit experiment, dissected and cult something. Horrible, just useless video. Didn't say a damn thing in the video. So I think we're almost done then. Oakley doke. Last 30 seconds. Have something to say, better say it. Alrighty then. I guess we've completed our task here. So till the next time and such.